In the middle of the Arizona desert, there is a place that looks like it was never meant to exist on Earth. A giant glass world, shimmering under the sun like a crystal fallen from another planet. For years, people whispered that this place was the key to humanity's future, a blueprint for how we might survive on Mars after Earth becomes unlivable. But behind the glass, behind the dream, there was something the world didn't see, something the creators never expected. A slow, silent collapse that revealed one of the most important lessons in the history of science. This is the story of Biosphere 2, the Mars dream that ran out of air. The idea began in the 1980s, a decade obsessed with space, technology, and the future. The time when some believed Earth would one day fail us. Among these believers were two unusual men: John P. Allen, an eccentric environmental thinker and showman, and Ed Bass, a quiet Texas billionaire with a fascination for big, visionary projects. Together, they wanted to build nothing less than a new Earth, a sealed, self-sustaining world that could support human life without any help from the outside. A living test of what a colony on Mars might someday require. Bass provided between $150 and $200 million. Allen provided the philosophy and the daring. And in the middle of the desert, construction began on a 3-acre glass city. It was a marvel, 1 million square feet of steel and glass, containing a rainforest, a savanna, a marsh, a coral ocean, a desert, and a fully functioning agricultural zone, all sealed off from the world. No air exchange, no water exchange, no life allowed to cross the barrier once the mission began. The crew would eat only what they grew, breathe only what the system produced, live inside an ecosystem as delicate and intricate as Earth itself, but much smaller and much less forgiving. To keep this miniature planet alive, engineers built something extraordinary: the Biosphere lungs. These were giant domes with flexible membranes that expanded and contracted as the air inside heated and cooled. Without them, pressure changes would have shattered the glass. It was, at the time, one of the most advanced experiments in ecological engineering ever attempted. The world watched as 8 people, 4 men and 4 women, prepared to enter the dome for a 2-year mission. They wore matching jumpsuits. They waved at the cameras. And on September 26, 1991, the massive airlock doors sealed shut behind them. Inside, the crew entered a world they hoped would become the first step toward Mars. Their food would come from a meticulously designed farm. Sweet potatoes, bananas, peanuts, rice, wheat. Everything had been calculated to keep them alive. But almost immediately, survival proved harder than expected. Farming for 8 people required long, exhausting days, often 12 hours of labor. The crew burned more calories than the farm could produce. Their bodies began to shrink. They lost weight. Their faces thinned. Their moods changed. The system was working biologically, but barely, and always at the edge of failure. But hunger wasn't the only unexpected challenge. Very soon, an uninvited army began to take over the dome. Ants. Not ordinary ants, but a species known as Paratrachina longicornis, the crazy ant, capable of spreading explosively in warm, controlled environments. They infiltrated pipes, wiring, and every hidden corner of the facility. At night, cockroaches emerged in huge numbers, turning the sealed world into a nocturnal battlefield. Species that the team had carefully introduced, pollinators, delicate insects, began to disappear. Some plants struggled, others overgrew. The entire ecological web began to warp. Inside a closed world, even tiny species can become giants. But the worst problem was invisible. Slowly, silently, oxygen inside Biosphere 2 began to drop. At first, no one panicked, but the numbers kept falling. 19%, 18%, 16%. The crew felt tired, breathless, foggy. Their thinking slowed, their sleep worsened. Eventually, oxygen fell to levels equivalent to living at more than 5,000 meters of altitude. It was as if the team had moved to the top of a mountain without ever leaving the desert. Something was stealing the air. Scientists outside looked for leaks, structural failures, anything that could explain the mystery. But the truth was more complex and far stranger. The soil inside the dome, rich in organic matter, was alive with microbes that consumed oxygen and released carbon dioxide. Normally, plants would absorb that CO2. But another reaction was happening in the shadows. The concrete structures inside the dome, still curing and chemically active, were absorbing the CO2 and trapping it permanently as calcium carbonate. The cycle was broken. A hidden chemical process was quietly devouring the atmosphere. The dome was suffocating. By late 1993, the situation had become dangerous. Oxygen had to be pumped in from the outside. For the world, it was the moment when the dream of a perfectly sealed miniature Earth cracked. For the crew, it was a breath of life, but also a sign that the system was not what they had been promised. And then, as the ecosystem struggled, the humans inside began to struggle too. The combination of hunger, exhaustion, low oxygen, and isolation created tension. Two factions formed inside the dome, splitting friendships and trust. Communication broke down. Arguments intensified. The unity the mission relied on began to fracture. Then came the injury. During routine work with a wheat thresher, one of the crew members, Jane Pointer, caught her hand in the machine and severed the tip of her finger. She had to be evacuated for surgery, then re-enter the dome. This event became a symbol of the mission's fragility, and outside observers wondered whether the experiment was still truly sealed or whether exceptions were being made behind the scenes. Meanwhile, outside the dome, a scientific revolt was brewing. Members of the advisory board, respected scientists including Tom Lovejoy of the Smithsonian, resigned, accusing the project of poor transparency, weak scientific controls, and an unwillingness to share data. Rumors exploded in the press: secret oxygen lines, hidden food supplies, manipulated numbers. Some claims were exaggerated. Some were partially true. Some remain unresolved. But by then, the public image of Biosphere 2 was falling apart. The final blow came in 1994. Billionaire Ed Bass, frustrated by management problems and internal conflict, fired the original leadership. To take control of the facility, he brought in a new executive to run the project, Steve Bannon, who decades later would become a prominent political figure. Bannon arrived with lawyers and with the support of U.S. Marshals. It was a hostile takeover of a scientific experiment. The crew, still inside the dome, protested. Two former Biospherians tried to break into the facility to warn the second mission team. Lawsuits followed. Security guards were posted. And by September 1994, the second mission was terminated. The dream of Biosphere 2 was officially over. To many, it looked like a failure. A beautiful, expensive failure. A project that tried to play God and learned how unforgiving life can be when it is sealed away from the world. But the story doesn't end with collapse. In fact, the most surprising part of the story begins after the dream died. In the early 2000s, the University of Arizona took control of Biosphere 2. The question changed. Instead of asking, can 8 people survive inside a closed world? Scientists asked, "Can we use this place to understand Earth itself?" The answer was yes. Biosphere 2 became a one-of-a-kind climate laboratory. Researchers built the Landscape Evolution Observatory, 3 enormous artificial hills instrumented with thousands of sensors to study how water moves through soil. They created controlled droughts, controlled floods, and heat waves that would be impossible to simulate outdoors. The massive indoor ocean became a testing ground for coral under rising carbon dioxide levels. The rainforest became a place to study how trees respond to heat and changing humidity. And a new sealed habitat called SAM, the space analog for the Moon and Mars, was built to test equipment and study human behavior in a pressurized environment. Ironically, the failure of the original mission turned the facility into something far more valuable, a place where Earth's future climate could be tested safely, where ecosystems could be pushed, stressed, and measured, where scientists could learn things that might one day help billions of people. And along the way, Biosphere 2 taught NASA and SpaceX some crucial lessons. Lessons that made future Mars plans more realistic. First, don't try to recreate a whole ecosystem in a closed environment. It is impossibly complex, full of feedback loops that can spiral out of control. Second, closed habitats need precise mechanical life support systems, not living soil that can malfunction. Third, crews isolated for long periods need strict psychological support, leadership structure, and conflict mitigation tools. And fourth, Earth's ecosystems are delicate beyond imagination. Rebuilding them from scratch is far harder than it looks. Today, when visitors walk through Biosphere 2, they see something beautiful. Waterfalls, coral tanks, towering trees, and sunlight bouncing off glass. They don't see the sleepless nights, the hunger, the arguments, the oxygen crisis, the invasions of insects, the lawsuits, or the financial battles that almost tore the place apart. They don't see how close the dream came to collapsing entirely. But all of those things happened here, and they matter. Because Biosphere 2 is really a story about ourselves, about how humans behave when trapped inside a tiny world, about how our systems, ecological and emotional, buckle under pressure, about how easily we underestimate the complexity of nature, and about how our biggest dreams can fail in ways that teach us more than success ever could. When we imagine living on Mars, we imagine adventure, exploration, and hope. But Biosphere 2 reminds us of something far more important. Life is fragile. Ecosystems are fragile. And the planet we live on is irreplaceable. Before we dream of building new worlds, we must understand the one we already have. Today, the great glass lungs of Biosphere 2 still rise and fall, inflating and deflating as the temperature changes, breathing in their slow mechanical rhythm. Inside, water still evaporates, clouds still form, plants still photosynthesize, and scientists still measure every subtle shift in this controlled world. The dome that once tried to replace Earth has become a place to protect it, a place to learn, a place to prepare, not for escape, but for understanding. And if there is one lesson Biosphere 2 leaves us with, it is this: Earth is not easy to rebuild. And once lost, it may be impossible to replace. So when we look at that shimmering glass city in the desert, we see more than a failed Mars experiment. We see a warning. We see a teacher. We see a monument to ambition, to error, to resilience, and to the delicate balance that makes life possible. There, among the steel beams and the echoes of old dreams, we are reminded of a truth that humanity must never forget. Before we try to build a new Earth somewhere else, we must learn how to take care of the one we already have. If you enjoyed this journey into the forgotten side of science, don't leave just yet. There are countless hidden stories like this one. Stories of inventions, mistakes, near disasters, and ideas that shaped our world in ways we never saw coming. So if you want more, make sure to subscribe, tap like, and share this video with someone who loves deep, untold history. And before you go, there's another mystery waiting for you right now. Click on the next video, and I'll meet you there, where the next forgotten truth is already unfolding.